This is video 1 for your Unit 3 test review for PreCal covering solving triangles. And before we start working the example problems here, the three most important things that you need to know from this unit and going into this test are: 1, when do you use SOHCAHTOA? So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent is opposite over adjacent. When do you use law of sines? And when do you use law of cosines? So those are the three big key points in this whole unit. You need to know when to do what. And the basic two categories that you can split that up into is when you have a right triangle, a triangle with a 90-degree angle, you should use SOHCAHTOA. When you have a triangle that does not have a right angle that you know of, you either need to use law of sines or law of cosines. So that's the two big categories. You're either using SOHCAHTOA or law of cosines, law of sines. Those are the two major topics. So let's start with problem 1 here. Notice it says solve right triangle ABC. So we're going to use SOHCAHTOA here. SOHCAHTOA. And solve right triangle ABC, so we can draw the same triangle every single time. We can label A and B wherever you want. We just need to make sure that C is the right angle. Once I draw my picture, then I do have to put each component in the correct place in order to make sure I get the right answer. So side A is equal to 3. Remember, lowercase letters are side lengths, capital letters are angle measures. So this is 19. So we can just find angle A quickly. 90 minus 19 is 71 degrees. So angle A is 71 degrees. So all three angles are accounted for. Now we just need the other two sides. Remember, I could have done this 180 minus 19 minus 90, and I would still get the 71. It's just a shortcut in a right triangle. You already know that 90 of the 180 is taken up by this angle, so you just take the other angle they give you and subtract it from 90, and that's just a shortcut the way I did it here. Okay, now you have a lot of choice when you're doing SOHCAHTOA. Let's say I choose to use this angle, and I'm going to choose to find side B first. So if that's my choice, then I take this angle and I have the opposite side and I need the adjacent side, so that gives me tangent that I need to use. So tangent of 71 degrees is equal to opposite 3 over adjacent little b. So cross multiply and divide, and we get b equals 3 divided by a tangent of 71 degrees. So in my calculator, I'm already checked to make sure I'm in degree mode, and that's important. And we get side B is 1.03. And now I can stick with that same angle if I want, and I can even stick with this side. And that from this angle I have the opposite. I want the hypotenuse, little c, so opposite and hypotenuse is sine. So sine of 71 degrees equals opposite 3 over hypotenuse little c. Cross multiply and divide, and we get 3 divided by sine 71. So for efficiency's sake, I'm going to copy this down, change this to sine, and I have it done. 3.17 for side C, and we are done with problem 1. Okay, problem 2, find the area of right triangle ABC. So keywords, right triangle. So that's going to determine our best approach here. So we'll draw this triangle ABC, label it A, B, and C. And A is 4.7, C is 18. We know that this is a right triangle here. So I need to find the base of the triangle here in order to get the area, because we're going to, for a right triangle, we use base times height over 2. I have the height, I just need the base. So we can use Pythagorean theorem. That would be the most appropriate based on the given information. So that would be our side length B is equal to the square root of 18 squared, the hypotenuse, minus 4.7 squared. So 18 squared minus 4.7 squared Square root of all that is 17, we'll round to 17.4. So side B is 17.4. And now we just multiply these two sides together, divide them by 2. So I've already got 17.37 there in my calculator. So times 4.7 divided by 2. And I get 40.83. So the area, K is often used for area of a triangle, 40.83 square units is the answer to problem 2. And now we move on to 3. Okay, problem 3. Two planes leave an airport at noon. How far apart are they at 2 p.m.? So they've been flying for 2 hours. That's the important part there. When one flies with a speed of 180 miles per hour at a heading of 340 degrees, and the other with a speed of 200 miles per hour at a heading of 250. So we need to know our navigational angles here. Navigational angles are measured off of a due north line. Due north is 0 degrees, and clockwise is positive. So we'll make our due north line here, and we'll make this first plane, I'll underline it in red, and we'll use red, and then second plane we'll use green. So 180 miles per hour for 2 hours. Don't forget about that. Let's write that down. 2 hours at 340 degrees. So it would be almost all the way around at 340 degrees right here. Sketch it that way. And this 180 miles per hour for 2 hours. So 180 times 2, 360. So the total distance is 360 miles. Now, for the part in green here, 250 degrees, so 270 would be over here. Well, let's start here. 0, 90, 180, 270, so 250 back this way. So we'll label that one as 250 degrees. Should go back and label the red as 340 degrees. And now this line here, this terminal side, 200 miles per hour for 2 hours, so that'd be 400 miles is the length there. And we want to know how far apart are they, so we're finding this side length right here. So if we find out what angle theta is right here, that will help. So 340 minus 250 gives us that angle, because the red part is 340 degrees and the green part is 250 of that. So the leftover would be 340 minus 250, and that's the angle inside of our triangle here. So that's a right triangle. It's a 90-degree angle here. So we can just use Pythagorean theorem here, and we'll have it made. You can use Pythagorean theorem as long as you have a right triangle. Don't forget that. You can't use it if you have a non-right triangle. So our answer, the distance, is the square root of 400 squared plus 360 squared. So we'll put that in our calculator, and we get a total distance of 538 miles apart. So they are approximately 538.1 miles apart. And that answers problem 3. All right, problem 6. If you notice, I skipped 4 and 5. Those were just asking about what is the cosine law, what is the sine law, in terms of listing it out. So you'll have that when you take the test, so I'm not going to cover that here. 6, graphically show how to add these two vectors with the parallelogram method. All right, so we take vector B here, like this. This is vector B. Attach vector A to it like this. This is vector A, and then we make a parallelogram out of it. So we make a parallel with B over here. We make a parallel with A back this way, and our resultant vector, when we add it, would be this vector right here. So that is our R resultant. That's how we would add these using the parallelogram method. Let's look at 7 next. 7, graphically show how to add these three vectors with the head to tail method. All right, so head to tail method. Let's start with vector A here, and I'll attach vector B to it, head to tail. So vector B going back this way like this, and then I'll attach C to that, head to tail. So back like that. And then our resultant vector, when we add those, goes from the tail of the first to the head of the last. So there is our resultant vector right there. So that answers number 7. We'll stop this first video here, and in video 2 we'll pick up with problem 8 on your review.